Okay, hi everyone. I hope I'm audible. Yeah. So, hi. And today we have a Div3 round, Codeforces round 725. So, like a lot of people have already registered. And like Div3 contests usually have a lot of participants. So, that is not like a surprise for me. Okay. Yeah, so the main aim here will be to solve all the problems and solve them really quick. But yeah, if I get stuck on some problem, then that wouldn't be possible. But my main aim in every Div3 contest is just to solve every single problem that is there in the contest. So let's see how this one goes, and I hope my Sublime is working fine. Okay, yeah, it seems to be working fine. And yeah, it is getting recorded, so great. Okay, let's go. Okay, problem A is solving a new computer game. This has n stones in a row. The stone on the position I has integer power ai. Okay. Can destroy either stone on the first position or stone on the last position. When Polycarp destroys the stone, it does not exist anymore. Now Polycarp wants two achievements. He gets them if he destroys the stone with the least power and the stone with the greatest power. Help Polycarp find out the minimum number of stars. Okay. Right. So if I could just find out the positions of the maximum and the minimum, will that be fine? Uh, then there is like just a very small casework here. Okay, I hope the syntax here is correct. I'm not really sure about the syntax of finding the minimum element and the maximum in a vector. But let's see, if we don't get an error, then yeah, it would be fine. Okay, let's see. Index 2. I think this does not work here. Come on. Star min element, right? Okay, but that will only give me the exact minimum element, right? I wouldn't get the index here. Okay, let's see if this is fine or not. And it has to be v1. Oh my god. Okay, 0 and 1. Okay, so there are basically two cases. Answer 1 equals to what, n minus min 1. Answer 2 equals to max 1 plus 1. Answer 3 equals to min 1 plus 1 plus n minus max 1. Okay, I think it does not work here. Let's try it out like this. Oh my god. So we have 2, 4, 5, 3, 2. Okay, this seems fine. N minus min 1. Then we have max 1 plus 1, min 1 plus 1, and n minus max 1. This should be fine. Okay, great. So basically there were three cases. Either you go from left to right completely, or from right to left completely, or you cover both of these stones. I mean the left one from the left side and the right one from the right side. So yeah. Moving on to problem B. Has n friends, the ith of his friends has ai candies. Polycarp's friends do not like when they have different number of candies and all. Okay. He chooses k, an arbitrary k arbitrary friends. Let's say he chooses index. Okay. During distribution for each of ai1 candies, he chooses new owner. That can be any of n friends. Note that any candy can be given to the person who has owned that candy before the distribution process. Okay. K is not fixed in advance and can be arbitrary. Your task is to find the minimum value of k. Okay. If this is the given array, then Polycarp should make the following distribution of the candies. He chooses k equals to 2. Okay, a2 plus a4. Distributes their candies among all n friends. Oh, alright. If he chooses this, two candies can go to person. I don't understand this here. Distributes their candies among all n friends. Oh, okay. Two candies. Oh, right. Two candies can go to person 3 and the other one can just shift. Cannot choose k equals to 1. Oh, okay. He has to choose the minimum k and he has to choose it only once and do all of the reordering, right? Right. So first of all, the sum has to be divisible by n. And what else? Yeah, that is the main condition here. We can always select all of these n, people and distribute their candies. That will always work. Okay, if it is already distributed, we don't need to do anything. Right. Apart from that, what else do I need here? Like I know my x, that this has to be the value. So all I can do is just choose all of these people that have greater than x value, right? Yeah, that should be fine. Okay. Now what else do I do? Now I need the sum also. So what is the value of these numbers? Okay, let's just keep it long only. Makes it much easier. Right. Else what do I do? Else I just calculate the count of the people that have greater than these candies. V1 at I is greater than what? Greater than P. See out count one end L. Alright, let's just test it. Okay, great. Now I should also make my N as LL. Just to prevent any overflows that might happen. So this should be fine. Let's submit this. Okay, cool. 2 problems done. Moving on to problem C. So you're given an array A of n integers. Find the number of pairs ij where the sum of ai plus aj is greater than or equal to L and less than or equal to R. Okay. For example, if n equals to this, so I just need the number of pairs, right? So I can easily find out what are the number, like I can iterate on this index, like the I index, and find out how many, numbers are greater than or, okay, I will have to sort of do some binary search here. Right. And less than or equal to R, L equals to 4 and R equals to 7, then, right. Okay, so for every number I will have a range. Like if I say I have already included x, so L minus x should be greater than equal to 0, and sorry, x minus L should be greater than equal to 0, and what? Okay, let me write it down here. Like since the contest is not rated, so I don't really worry about speed so much. So yeah, so if I choose x and I also want to choose y, then I want this condition to hold. So y should be what? It should be less than equal to x minus L, and similarly y should be what? X plus y is less, sorry, let me put it here. X plus y is less than equal to R, so I want y to be, oh, okay, sorry, this should have been L minus x. X plus y should be greater than equal to L, that is fine. So y should be greater than equal to L minus x, that is fine. And what else? Y should be less than equal to R minus x. Right. So this is like P and Q. Okay, so I want the number of, indices for which this holds. Right. So maybe I can make use of a set here. Right, so we have set of pairs. Right, cool. So here is what I do. L minus v1 at I and LLY equals to R minus v1 at I. So now I will have to search the values that are in this range, right? Okay, cool. So maybe I can use an ordered set here. That should help with the indices, right? Do I have a pair here? Yeah, that is fine. P equals to, I have this X and I need its index, right? So I can put it -1. And I need this value, so I can put an infinity here, right? Yeah. A dot order of key. So I have P1 and LL. So I should be putting it like this, X minus 1, and I can keep it infinity as well. So I have P2. So answer plus equals to index 2 minus index 1, right here. And I also need to insert into my PPDS. So what I'll do is I'll insert v1 at I, comma I. Right, let's see. Two 701, yeah, seems fine. Okay, so it actually took a lot of time because I am using a very heavy data structure here. But I don't think a PPDS is actually required for this question. Like, it should be solvable without a PPDS as well. But yeah, if you know about PPDS, then it becomes really easy because you can just quickly find out the index of any element in a set here. Whereas doing it with a set naively would take order of n. You're given two integers a and b. In one turn, you can do one of the following operations. Take an integer c and e should be divisible by c. Okay, replace a with a by c. Take an integer c. You can do one of the following operations. A should be divisible by c. Oh, alright. Your goal is to make a and b equal using exactly k turns. For example, the number a equals to 36 and b equals to 48 can be made equal in 4 moves. Okay. Okay. So can I make them both equal to 1? Will that work here? Okay, in exactly k turns, okay? Right. A and B have to become equal. So the very first thing that I can do is I can find the GCD, because that is one number, I can reduce both of them to. Yeah, right. Right. I can obviously reduce them both to the GCD, and that will not take a lot of, what should I say? That should not take a lot of operations. It should only take 2 operations, and both of them will become equal to GCD. Right. So C has to be greater than 1, which is fine. Now, if I keep removing some factors from each of them, the biggest number that I can form that should be equal is their GCD, right? Yeah. So if I talk about 36 and 48, what else can I form from this? I can obviously make them both equal to 6. Can I make them both equal to 12? Yeah, I can. So 12 is the GCD. I can obviously convert both of them to their GCD. That will not take a lot of operations. What else can we do here? Okay, so here they have 2, 2 and 1. And they had 1, 2 and 1. Okay, after exactly k operations, they should be both equal, right? Can we make them both equal in between as well? Like, is that allowed? I'm not sure if that is allowed. Okay. Okay, first of all, let's talk about the maximum operations that we can do on a number here. If we have A, then if I can just find out okay, A needs to be converted either to its GCD, like the number that you can form is either the GCD or it is less, right? And if I have B, if you talk about k being equal to 1, let's consider this case first of all. If k equals to 1, then one of them has to be equal to the GCD, right? If k is 1, then one of them has to be equal to the GCD. If k equals to 2, then it is always possible. If k equals to 2 and both of them are not 1. Okay. So first of all, let's find out the maximum number of operations that we can do on a number. Like if I give you a and if I tell you to keep dividing it, how many times will you have to divide it? That is the question. So that can be found out in square root of n time. Okay, if they would have told me to do this in 5 operations, I can do that as well. Using exactly k turns. Okay, for 2 it is always possible, but let's say I had a number like, you know, 2 comma 2 comma 2 comma 2 comma 3. Then this becomes a 1, this becomes a 1. Okay, so if A divides B or B divides A, then I know that this is possible in one operation, right? Apart from that, what else do I know? If they both don't divide each other, right, then this is always possible in 2 operations. Done. What about 3? And what about some very huge numbers? Like if k is really very huge, what do I do in that case? If k is greater than 30, then I know for sure that, okay, not greater than 30, I would say. If k is greater than 100, let's say, then dividing all these operations into both of these numbers, I get 2 to the power 50 and 2 to the power 50, which is just huge. So that should not work. So if k is greater than 100, this is never possible. Fine. And can I make an algorithm that works in square root of n? I'm not really sure about that too. 1e9 0.5 31,000. So ideally this should not work. Okay, first let's talk about making them both equal. If I can just find out the GCD, then GCD is the biggest number that can be, that they both can be made equal to. What do they mean by this exactly k turns? Maybe there is some constant time answer to every question, every test case here, and I'm maybe not able to understand. So if you have 36 and 48, so they both don't divide each other, so you at least need two operations. So you do that first of all. Right. Oh, okay. So if they both don't divide each other, then I just have to see if k is not very large. That is all that I have to see here. So the very first thing is LL A comma B comma C. Let's keep this k only. So if A divides B or B divides A, then our answer is at least, not at least, I would say, okay, if they both are equal. Okay. If they both are equal, then then I just need to see how many times can I divide A, because it can obviously be reduced to a 1 instantly, and talking about B as well, it can be reduced to a 1 instantly. Right. So here if k equals to 1, then you see out no. Yeah, this is obvious. Okay. If they both are equal and k equals to 1, then this is not possible. Otherwise you find out number of steps. Steps 1 equals to steps of A. Steps 2 equals to, and are they also telling us 0 here? No, they're not giving us 0, so that is fine. Steps 1 equals to this, and steps 2 equals to steps 1, right? So here what I need to do is, if steps 1 plus steps 2 is greater than equal to L, is greater than equal to K, then you see out yes. Right, so we are done with this case when they both are equal. Now let's talk about this case. If A modulo B equals to 0, or B modulo. So here if B modulo A equals to 0, then I just swap them so that I consider both of the cases here itself. Right? Now what do I do? Now, like, I need at least one step, that is fine. and that is already available, right? So all I need to check is, yeah, again, steps 1, steps at A, uh, steps 2 equals to steps at B, right? So here if steps 2 plus steps 1 is greater than or equal to K, right, this is fine. Now similar will be the case here. Continue. So now if K equals to 1, right, otherwise I just do the same thing again. Oh, right. So what I do here is I just find out this steps 1, steps 2. Okay. Right. So if either of these is the case, then I at least need one step. So that is already satisfied because K is already greater than or equal to 1. Right. So here I need to find out the number of steps. Okay. While A modulo P equals to 0, I do count plus plus. So I'm not really sure if this will work because this is very close to the time limit. But yeah, let's see. Okay, maybe there is some issue here. Yeah, seems like. So let's try to do this. Yeah, this seems to be working fine. So I have A modulo I equals to 0. While A modulo I equals to 0, what do I do? Count plus plus, count 1 plus plus, and A divided by equals to I. Right. Okay. So I'm not really sure why this is not working. Okay, this had to be this. So I don't really need this, nah. That is the thing. I don't need this. I only need this. Is there an infinite loop here? So seems to be fine. But yeah, again, I'm not sure if this will work. Because there are like a lot of test cases. Okay, I think I will get a TLE here. So yeah, it was expected, kind of. So how exactly do I optimize this? So I cannot calculate these number of prime factors for every number here. That is the main issue. So everybody is like maybe getting TLE here. Okay, they are getting wrong answer. Okay, can I like do this question without finding the total number of steps? Will it be always possible after a certain point? Okay, I need the shortest, smallest prime factor that divides a number. First of all, this. So I need this quickly without, using a sieve. Okay, can I like find out the number of 0.5 36123? Three six one two three. Because after all, this is all that I need, right? I can find out the size of this vector. Okay, 3836. That is like 3000. So I think this should be fine. Yeah. So if I have this, so if I is greater than A, then you break. While A modulo I equals to 0, A divided by equals to I. So this should also be fine now. I don't know if this will in any way fasten up the process. Should I create like huge numbers here? Because initially I was going for all these numbers, right? I only needed primes. So this should help, but I'm not sure if it will prevent the TLE. I'm definitely doing a lot of less operations here. 36123. I hope it was not 38123. Oh, okay, great. So here, like, how did I optimize it? First of all, I found all the prime numbers less than the square root of, the maximum number that we can get. So it turns out that the number of prime numbers is very, very less, like almost 1/10 of the actual numbers that are there. So this way, like, I'm doing 1/10 of the operations that I was doing initially. So yeah, great. But I definitely think that there must be an order of one solution for it, like order of t type of a solution, wherein you answer each test case in order of one. Okay. So let's get to this problem, F problem, because turns out that people are able to solve F easily, like more easily than problem E. So let's try out problem F. You're given two integers L and R where L is less than R. We will add 1 to L until the result is equal to R. For each such addition, let's look at the number of digits that will be changed after it. If L equals to 909, then adding 1 will make it. Okay. Changed digits always form a suffix of the result written in the decimal form. Yeah, that is right. If you want to get R from L, okay. So if I can just find out the number of changes that we have from 1 to n, that should help, because then I can find out the number of changes till R minus the number of changes till what? Till L. Right. So I need the number of changes here from 1 to n. Okay, let's try to look at some pattern if there is any in this. So if I go from 1 to 9, then there are like n changes. So as soon as I go from 9 to 10, there are like 2 changes here. And from, again, 10 to 19, there are like 1 change. From 19 to 21, there are 2 changes again. From 19 to 20. And similarly from 99 to 100, you will have 3 changes. Right. So the number of times the whole number is divisible by 10, that many times you will have like 2 changes. The number of times it is divisible by 100, you will have 3 changes. This seems fine. Okay. Okay, answer plus count 1 plus equals to a by I. Right. So LL count 1 equals to 0. Cool. Okay, that was like a very easy problem. Maybe that is why it has so many submissions. Okay, like which problem should I try out now? Should I try out G or E? I think I should try out G. Let me look at the people who solved this. Okay, so, and let's look at this. I think we can go with G here. Has X of red and Y of blue candies. Using them, he wants to make gift sets. Each gift set contains either A red candies and B blue candies, or A blue candies and B red candies. Okay. Any candy can belong to at most one gift set. Fine. Help Polycarp to find the largest number of gift sets he can create. Okay. 10 and 12. So if you have like 5 red candies and 2 blue candies, yeah, that is possible. Oh, all right. So can I like do a binary search here? I think I can definitely do a binary search on answer here. Apart from binary search, like if I say that I want X gift sets, then I can have L red candies and L minus, yeah, L minus X into P basically. Oh, all right. So like we can even switch them. That is the case here. So that actually makes the problem interesting. So yeah, we can definitely do a binary search on answer, but let's say I tell you that I have to create n gift sets, then what would be optimal here? If there are n gift sets and I tell you that I put like if I tell you that I put X type, X times I put the red candies first, then I have X into A plus n minus X into B. That is the number of red candies that are being used, and then you have n minus X into B. Okay. If I tell you that I put the red candies X times first, then I'm going to use A times of X and n minus X times of B. Otherwise, I'm going to use X times of B. Yeah, and plus n minus. Okay, let me just write it on OneNote. It should be easier to understand from this. So the very first thing is that I will be doing a binary search on answer here. Okay, and yeah. Apart from that, if I say that I have to create n gift sets, and I say that out of these n, for the first X gift sets, I put the red candies first. So how many red candies will get used? It will be X into A plus n minus X into B. Right? Yeah, this is the number of red candies that are being used. And if I talk about the blue candies, then it will be the blue candies will be n minus X times B. Sorry, n minus X times A plus what do we have? Plus we have X times B. Right? These are the blue candies. Sorry, I had to write a B here. So let's analyze this equation. This is like n times B plus A minus B times X. And if we look at this one, then it is n times A plus B minus A times. Okay, just give me a minute. right? Now what do I know from this? So if A is greater than B, right? Yeah. If A is greater than B, then okay, we cannot analyze this like this. Let's say this is like a constant, we don't really care about this. Let's remove this and let's remove this. We don't really care about this for now. Okay, now if I increase my x, yeah, if I increase my x, the number of red candies, they will what? It depends now. If A is greater than B, then if I increase my x, the number of red candies will increase, right? So can I do a binary search on x again? And here the number of okay, the thing is that one of them, if I choose any x, then after increasing my x, what happens? One of them reduces and the other one increases, right? So this will like always happen. So if I have this x, yeah, let's try to consider it like this. If I have my x value as something here, let's keep it on a number line. If I have my x value here, then my red candies can be somewhere here and my blue candies can be somewhere here. Okay. Now if both of these are greater than what like I have what do I have? I have x and y. So if both of them are greater than x and y, then I cannot do anything, because even if I increase my x, it does not work, right? But let's say if both of them are less than x and y, then it is always possible. Now if one of them is greater, okay, yeah, this should be fine. Like we have a double binary search here. So talking about R, I have this as the equation, a times x plus n minus x times b, which makes it n times b plus what? Plus a minus b times x. And for this is R, this is for blue, I have this n times a plus b minus a times x. Yeah. Okay. So let's try to create this function, which will be our predicate function for binary search on answer. So first of all, I can have these as global n a comma b comma. Is this the order that they're giving us the input? Okay. So we don't need n here. If possible for mid, then what do? Then I just say that start equals to mid plus 1. else I do end equals to mid minus 1. Right, now if I have to check if it is possible or not, so this is end. So end equals to 1e9. So this is my value of x, and reds equals to what? Equals to n times b plus what was the equation here? A minus b times x. A minus b into mid. N into a plus b minus a times mid. Okay. So if reds is less than equal to blues, sorry, if reds is less than equal to x and blues is less than equal to y, then you return what? This is the very first thing. Apart from that, if reds is greater than equal to x and blues is greater than y, sorry, it has to be both greater than, then you know, if I increase my x or decrease it, anything, it does not matter. Apart from that, what else can I do here? So if reds is less than equal to x, then if I increase my mid, okay, now there are two cases. If a is greater than equal to greater than b, then if I increase my mid, okay, here it should be mid minus, okay, if reds is greater than x, it should be, so if reds is greater than x and a is greater than b, then I need to reduce it. But if a is less than b, then I need to increase it. Yeah, else what do I need to do? Else if a is greater than, if a is less than b, okay, so mid is the number of mid is the value of x. So if blues is greater than y, so if b is greater than a, then if I increase my mid value, this will increase. So what do I do in that case? Right, so let's test it. So it says 3 0. 8 is also possible somehow in this case. So if I have if I have 8 into 1 and 1, what was the case for 8? This was the case, right? So let's test it. Okay, maybe there is some infinite loop here. Okay, no infinite loop, then let's try to test it with possible 8 now. So the very first thing is, if n is greater than x, or n is greater than, sorry, like these are the total, right? So return false in this case. So end can be only till x. Right. Start has to be from 1. Oh, okay. This is fine. This can be till n. Right. So this is fine. It was just unnecessarily going into negatives. That was the case. Yeah, seems fine. Okay, great. So like, yeah, this was a pretty cool question where I had to do like 2 binary search. First on n, then on the value of x again. So yeah, great. Now only this E problem is left. So I think I can try it out now. Okay, let's try out problem E then. So Polycarp came up with a new programming language. There are only 2 types of statements in it. Assign the variable named x the value s, where s is a string. For example, okay. Note that s is the value of a string, not the name of a variable. Right. Between the variable contains exactly 1 space. Oh, okay. Assigns the variable named x the concatenation of values of 2 variables a and b. For example, if the program consists of 3 statements, it is guaranteed that the program is correct and the value are previously defined. All variable names and strings only consist of lowercase letters. is the number of occurrences of string haha in the string that was written to the variable in the last statement. Oh, all right. In the last statement. Oh, okay. So is there like a limit on the size of a string? Does not exceed 5 characters. Oh, all right. So let's look at this on OneNote. So I don't really need to store everything about a string. That is the main thing here. So if this is a string, then what exactly do I need to store? First of all, I can store the number of occurrences of the string haha in this one. And next, what do I need to check? If this contains AHA, HA, A, yeah, like that is how you can merge, right? So, right. So all I can store for every string is, like, if I store the number of occurrences of string haha in this, let's say this is pp, let's say this is p, and then let's say this is your string. So I can just keep a boolean variable which tells me if there is an a here, another one tells me if there is an ha here or an aha here or not. Like that is how you can complete it, right? By merging here. And similarly, I can keep a track of its substring. Oh, all right. So this can basically like be stored in a map. Yeah, a map should be fine here. And n is very less, so like anything quadratic, cubic, anything should work here. So now what do I need? So I can keep a struct. And how will I merge two structs here? Like if there is one this and this. So if there are p1 and p2, then the first answer is p1 plus p2. Then I check if an a is present here and an ha. No, it cannot start with an a, right? It has to start with an ha or an h or yeah, or an h. Right. So for the suffix, I need to have this h, hah, and for the prefix, I need a, ha, and aha. Right. So I will have to keep a track of both actually, and that can be done. That is not at all difficult. Right. So first of all, you have this ID. Then what do you have? Count. What do I name it? First of all, I need a prefix and int. Okay. Int prefix equals to 0, suffix equals to 0. Okay. Like that can be used as a bit mask. And then I need int count. So I can keep it like an LL count as well, LL number, right? So okay, so here I need to calculate the number of occurrences of the string haha in this, right? Okay, let me increase the size. I comma 4. So first of all, number equals to 0, prefix equals to 0, suffix equals to 0, right? So then I have number plus plus, right? So if n is greater than 1, n is greater than or equal to 1, and a at 0 equals to h, then you do or equals to 1, okay, I can have two different functions, void fill suffix. Let's name this also like this only. Yeah, so I have the string a, yeah, so if n is greater than or equal to 1 and a at 0 equals to, what else do I need here? Greater than or equal to 2 and a at or equals to 2, and if n is greater than or equal to 3 and a dot sub str 0 comma 3 equals to HAH, right? Then what do? I just do or equals to 4, right? Similarly, I do fill prefix. So if n is greater than or equal to 1 and a at n minus 1, a dot sub str n minus 2 n minus 3. So if this is equal to what? Equals to an a. Okay, let's look at it like this. What will h get merged with? It will get merged with HAH, right? So I do prefix or equals to 1. Right, this is fine, and here also prefix four. Okay, right. Okay, we are done with this. Now let's look at merging. Okay. Okay, what just happened here? Right. So here I will have S number equals to 0, then you have prefix equals to a dot prefix, suffix equals to b dot suffix, and plus equals to dot number plus equals to b dot number plus equals to okay. So now what we have, if prefix and 1 and pre okay. Instead I can do this now. If a dot suffix and b dot prefix number plus plus. Okay, this is fine. Now what do I need here? So I need a map of, okay, right, let's just take the input so that template 2 is invalid. Okay, struct, and I need a semicolon here. Prefix. Oh, okay. Right. So this is fine. While n minus minus. Okay. So if b equals to colon and this, then what do? I do m at, okay. Last dot assign string c and m at c equals to, sorry, m at a equals to, right, c in okay, I've already taken this c, so b equals to c, c in c, c, right. So now what do I do? Oh, all right. Last equals to m at a, and last dot what was this function? Assign string. Last dot merge m at b comma m at c. Right, let's see. So let's try it out.